what are some of the things we're going to be looking at today in these burns today?
Absolutely. So this study actually continues the project we began last year, looking at the cardiovascular and chemical exposure risks that firefighters face in their job today. So last year we were focusing on the typical response environment that we have. Today we're looking at training scenarios. So the scenario we're going to focus on today has a pallet and straw fuel load. It's pretty typical for training academies throughout the state, throughout the country. We've also looked at other options, other types of training that's done in addition to those. So we'll also do a scenario with the same group in 2 days that will include some engineered wood products, some OSB. That's commonly used these days because it gives slightly different smoke characteristics and it changes the environment a little bit. We're also going to do some scenarios where we don't have any heat in the structure. So it's going to be a theatrical smoke with a digital fire system. So we're going to look at the impact of the training environment on what our firefighters are exposed to. And we're looking at chemical exposures, we're looking at the cardiovascular strain, we're looking at heat stress, we're looking at heart rate, and all those things, not only can we compare to each other, we can compare back to the scenarios that we did last year.
And we've got some neat partners out here. With us today also is Eric Roden, Editor-in-Chief of Fire Rescue. We've got some neat partners. There's NIOSH, there's Denise Smith, also
right.
with the University of Illinois, but she's also with Skidmore.
Absolutely.
And then we have our friends from UL and NIST. So what are those folks, guys, doing out here, and what's their point?
Yeah, so the same crew that we had last year, we brought back the team. So UL is going to be focusing on measuring the buildings, what's in the building, what comes out of the buildings, looking at the heat in particular, looking at the temperatures in the structure, and some of the gas concentrations that we're interested in. NIOSH is focused on kind of the chemical exposure aspect of things. So they're going to be measuring different things about what's produced in the environment, not just the carbon monoxide and the oxygen concentration there, which is what UL focuses a lot on, but they're looking at the polycyclic aromatic hydrocarbons, or PAHs, volatile organic compounds, VOCs, hydrogen cyanide. So many of these things we don't expect to see as much of a concentration here as we might with the typical furnishings. We're not looking for flame retardants this year like we did last year because we don't expect any flame retardants in the pallets and straw that we have. They're also looking at 3 different levels. So we've got the environmental level, which I just described. They want to also know what gets on the gear itself. What does the gear protect us from? So when the firefighters are moving, they're going to have these pumps that are attached to their bodies, so we'll know what is around them. What could they be exposed to if we weren't wearing full protective equipment? So we'll measure all of those gases in their area, and then we'll look at what gets on the gear. When they get out, they'll take samples in there off of the surface to say, this is what we actually found deposited on the gear. At the end of the scenarios, we'll actually put those in a chamber that will measure what off gases from them. So not only what gets on the gear, what later comes off of them. If you're taking your gear home in a car or personal vehicle, that might expose you as well. And
how long will you study that, Doc? How long will you take a look at that?
The gear?
Yeah.
We're looking really at the 15 minutes after the last fire, because in particular the volatile organic compounds, the VOCs, off-gas relatively quickly. The good news is that if you let the gear air out, what we believe we're seeing from the first scenario is you let the gear air out outside of the cab, a lot of those things will go away. They get away relatively quickly. Now there's other things that stay on longer, such as some of the particulate, and there's other chemicals with those particulates as well. So we're focused right now on that volatile compound, but we're also going to look at how gross on-scene decon can remove some of those things. And we'll have slightly different things on the gear when we have pallet and straw fire versus some engineered wood products, versus also we'll expect to see something that'll get on the gear with the theatrical smoke. Right? It's not just water. There is some other compounds in there. So we're looking at all of those things and comparing them. And again, back to what we saw from the structures last year. When we had beds, we had couches, we had chairs, we had the typical furnishings that you're going to have in a house that we're going to respond to. You can compare all of those.
So one of the other things that's going on here is that Dr. Horn and Dr. Smith and all the other researchers out here, Kenny Fent from NIOSH, Steve Kerber, what they're looking at are many different facets of what's going on in the training environment. So we're going to be looking at the instructors and their physiological responses because they repeat it over and over and over again. We're going to be looking at the fidelity of the fires. In other words, compared to what Dr. Horn and all these folks did last year, what are the heat release rates? What's the intensity of the fire? What's the growth rates? How realistic is it? And then we can start to determine down the road how we want to conduct training in the future so that we can teach firefighters what a fire is really going to look like so that we
Absolutely.
get some kind of fidelity matchup, and we start to look at risk reduction in terms of training, which is really important.